Okay, welcome everybody. Um, yeah, talking about going global with Nomad and Google Cloud Platform. First of all, a little disclaimer, I'm neither affiliated with Google nor with Hashicorp. I'm a consultant at Xebia, specializing in continuous delivery and data center automation. And as such, we encounter these products, and I'm quite a fan of the Hashicorp tooling, such as Nomad and Consul, which we'll explore this talk. So, going global, why bother? Why not just have everything in your data center, your own data center, or one of Google or Amazon, and serve everyone from there? Just pick anyone. This is the current list of Google data center locations, and they will be expanded, so plenty to choose from. So for this talk, I'll focus on two of them, two benefits of having a globalized experience. And the first one is latency. Latency costs, and in an experiment that's already conducted 10 years ago by Google, it turned out that half a second extra latency could reduce the amount of traffic and revenue by 20%, so that's quite significant. And actually the latency between Europe and Asia is around half a second at least, so that's something to be able to improve. So the other thing we're focusing on is failures, because even if you're serving slower, it might not be that bad, but if your data center, local data center is down, or just, well, first of all, the process, the server, availability zone, or even the whole region, then your users cannot reach your site. So what are we gonna use today? Our tool chest consists of the Google Cloud Platform, Nomad by Hashicorp, Consul also by Hashicorp, and we'll use an HTTP router from eBay, which is called Fabio, which also makes it a bit difficult to find it and not getting some large hunk as an image. So why Google Cloud Platform? Well, I could have used Amazon or Azure, but we use Google Cloud Platform a lot, for example, in training environments, because it's really fast. You get a VM in 30 seconds, so that's nice for tools in action talk. The concepts are clear and simple, so they're easy to convey and to understand. And also, since it's not around as long as Amazon, there's just a smaller, simpler website instead of 200 different features. What I also like is easy networking, because we want to stretch a global data center with connected networks and machines, and Google takes care of that. So you have just a flat networking in the 10 range, which you can reach from all your machines. And one part that's also very nice, it has a global load balancer, which we'll use today to automatically get our traffic routed to the nearest data center. So the other component is Nomad. Is anyone actually already using or trying out Nomad? No? For everyone it's new? Well, Nomad, you heard a lot about Kubernetes today, so I'd like to compare it with that, except that it's much simpler and has some other nice features, because it's just a single binary, which is written in Go, which you can just download and install. And it does a lot of things. It's a cluster manager, for your local data center. It does scheduling of your workload on it. It's also a task executor. So if you compare it with, for example, Mises marathon setup, it's all these different components like a Mesos master and a Mesos slave and a marathon all in one. It can do service registration, so that aids discovery of your services. And what I really like is that it's very scalable and has high availability built in, because it builds a cluster which is consistent. You can build it with 3 servers or 5 servers for redundancy, and all these servers will make sure they have the same state about the cluster based on a mechanism that's called raft. And actually that's now used in the swarm mode of Docker as well. And one of the nice things of that global state is that the Nomad can do concurrent scheduling decisions. So it's actually the only open source optimistically concurrent scheduler, which means that if you have a lot of cores on your Nomad servers, you can do a lot of scheduling decisions at the same time. And since it's optimistic, it will do the concurrently without locking. And in some cases, that will get a scheduling conflict, and then it will need to retry it further. But it's much faster than the other mechanisms. And in fact, the folks at Hashicorp, which have written Nomad, have done a 1 million container challenge together with Google. And the graph is here. So within 5 minutes, all these million containers were scheduled and started, which is pretty amazing. And in fact, they actually ran into some bugs in Docker. That's why they actually started a little bit more than 1 million containers. So before we go into the hands-on stuff, the tool in action, I'll show a little picture about the setup. So like I said, there are 3 servers, and they replicate and forward their state of the cluster. And then the clients connect to either one of these servers to get information on their, what they should run and what their state is, how many resources they have. So this is what we're going to build right now to start with, to get stuff, be able to deploy stuff on our cluster. So our goals are this: setting up the server cluster, setting up the client cluster, and start our first job, which would be a UI for Nomad, because it doesn't have one built in. So I think it's cool to provision your own user interface by yourself. So let's move to the command line. Since I'm a lousy typer, I wrote some small scripts that will do the most of the stuff for me, but a bit manually. So I've done the bash output, so we can see everything that's going on at the while it does it. So this creates 3 machines. One in zone West B, one in C, and one in D. Well, it gives a warning about the disk size, doesn't really matter. We are using CoreOS because that's our minimal OS, and we just want to run Docker, and it's already created, so let's watch it. They're already running, so that's cool. So we now have 3 machines running with CoreOS on them. There are small machines because we don't need anything larger for a small cluster. And usually, actually, I do the micro machines, but well, I didn't want to tempt the demo gods and have something gone wrong right here. So we can now log into our server, which also I'm too lazy to type out. So SSH to, oh, see, even a dot slash is too difficult for me. SSH Nomad. So this uses G-Cloud Compute to SSH to the server. I've done some port forwardings I'm going to need later on, but you can ignore them for now. So now we're on one of the first of the server nodes. So we can see Nomad has been installed here, and that's because we installed a startup script when we created the machine, server script, and basically the server script we have here. Where are we? Server script. So this is basically a shell script which downloads the binaries we need. Here it downloads Nomad, then it performs some configuration on it and runs it as a service. So that's what we have right now. And if we ask Nomad its status, it will take a while because it's not connected yet. It has not formed a cluster yet. So it's still lonely. So now we need to join the three servers together as a bootstrap so they know about each other. I could have automated this by including it in the server script, but I thought it would be nice to do it live here. So we would say server join, and then the other ones are called, well, let's do all three together. So now we have three servers together. So if we now ask the cluster, we have a full cluster, and we see that we have a leader which is making all the decisions. So in any case, when a task is scheduled, the leader is the one who decides which scheduling plan will proceed and which one won't in case of conflicts. And the nice thing is, if this one crashes, we have two left, and they can continue doing scheduling. There are some other interesting things to see, like you can see the data centers, and I've put them in the EU region. By default, the region is global to have everything in one same region. So now we can look also at the client side, because I've configured these servers to also act as a Nomad client, which means that we can actually schedule jobs on these nodes. Typically, you would use the Nomad servers just to perform Nomad, to run the Nomad server. But for the demo, it's nice to also run the UI and to later on do the service registry also on here. So Nomad. Node, really lousy typer. Node status, we see that there are three nodes ready, and we can schedule our first job. So we go to our jobs. And Nomad UI will be our first job. As you can see, this is not YAML, but actually Hashicorp's own configuration language, which is like JSON, but a bit easier, and it allows comments and stuff like that. So it's quite a nice language to do configuration. So we want to define a job Nomad in the EU region. we need to specify a list of data centers it can run in. So we want all the European ones, and for convenience, I've also added the data centers in other regions. So that might be handy later. Then we need to specify the type of the job. In this case, a system job. A system job is one that will run on all nodes that are eligible. This is another option is to have a service job, and then you can explicitly specify, like I want to have 3 instances or 5 instances, and this one just does it on all. Rolling updates is supported. That's not what we're going to look into now. Here is the group. So Nomad has a hierarchy where a job consists of different groups. Groups are the units that are scheduled on a particular node. So, and within a group, you can have multiple tasks that will be run together on this same machine. In this case, we just have one task, which is the UI. And we have a constraint. We want to run it on a Linux server. And one nice feature of Nomad is that it runs not only Docker job, but also native jobs, and it provides its own isolation with a change route and limited capabilities. So we can simply supply a static binary, in this case one built in Go, so it doesn't have any operating system dependencies, and directly obtain it, in this case from GitHub. Configure it with environment variables. We specify how many resources it wants, including a port for its communication. And we can also register it in the service registry, which we'll do later. So let's run the job. Nomad, well, let's first see what it will do. Nomad plan. This says it will create 3 instances because we have 3 server nodes. So if we actually run it, we'll see that it has completed. So we can look at the status. We see it running, Nomad UI. And we see it has created 3 allocations. It has allocated these tasks on 3 servers. And if we look at the allocation, 4.6, we'll see it has been started and it has used this HTTP port, which I conveniently forwarded to my local hosts earlier, well, somewhere here. So if we now go to localhost 3000, yes, we have a nice UI, and we can see we scheduled. Oh, come on. We can see we scheduled our outdrop, and we can zoom into the actual allocation and see the logging, like standard error, will show everything. So that's nice, but now we just have server nodes. We want to run an actual cluster, so we're also gonna install the client nodes. And for this, we use a managed instance group, because we can easily auto-scale this one. So we do the install clients, and it will also show what it's doing. First, it will create a template, which is like the actual commands or the parameters we gave to the instance create. But now this is a template which a instance manager can use to create more identical nodes, which are worker nodes. So again, we're going to watch it creating the nodes. The client script is basically like the server script, except that Nomad is configured in a different role. So they're almost all running. So if we look at the, come on, at the UI, we'll now see the cluster become live because now we have nodes also at the client nodes. So now we can run an actual job, our beloved Hello World job, in this case an incarnation also in Go, and it will serve a /hello endpoint. So we're gonna nomad run hello world. And we see it has been scheduled 3 times because we have specified this as a service job. We wanted to just run on the farm nodes through another constraint. So we should see it here at the jobs. Hello world is running. And if we look at the allocations, it's on all the farm nodes. And now we need to know actually what the endpoint is. So we're gonna look up the allocation again. Nomad. Oh, I'm running out of time. Nomad status. Hello world. Nomad. Status 267. And we see it's over here. So if we now do a curl to HTTP 132.0.8.180/hello. Oh, let's do our typing properly. Port number. Where was my port number? 48180. What? 48. I can't type something like that. Okay, I see I have 7 minutes left. I'll simply move on to the service discovery because the next step is to not have to look up in allocations to do service discovery, to find out where your services live. So we're going to use Consul, which is a very nice service registry, also by Hashicorp. And Nomad integrates very nicely with it. So once you start a Consul cluster, and here it's complaining because it's not having any actual servers in these data centers. But if we look at Consul, we see that we now have a Consul cluster. And then we should also have a Consul UI. 8.5. And now we see that it has registered itself and Nomad UI and also Hello World. So it's there after all. And for some reason I cannot access it. So I'm now gonna ask the service registry where it lives. So we can do that through an HTTP API, but also through DNS, which is pretty convenient. So we're going to use dig. We want to know about Hello World. World Service Console. Come on. We need to ask it on the console port. With DNS mask, you could also make it available through regular DNS port and combine it with your regular DNS. Localhost. Another typo. Hello world. So now we see the right locations, and then if we want to know the port, we need to ask a service record. So here we see that it has the different ports on different nodes. So if we want to put a load balancer in front of this to make this accessible to the public, then that's not going to work because the Google load balancer expects a fixed port. So that's why we're going to want to use a HTTP router, and actually one that knows about console and service registry. So I'm going to Nomad run Fabio. And this is also one of the ports that I forwarded earlier. So we can go to the admin port of Fabio, and it will have discovered the let's go down here. Where's my right at the bottom you can still see hello world. And I've created Fabio to register itself as well. So this will listen to a fixed port, and based on the host name which has been configured in the job, it will forward it to the right service. So now we can use this together with the global load balancer. So let's configure that right now. And we do that in Compute Engine. And then we should be just in time. Here are our running services. I've also already created some in Asia, which will hook up as well. We are going to the networking, load balancing. We want a new load balancer, HTTPS. And we want DevFox. We need a backend configuration to define where our services should go. That's nice that we cannot actually see it. Here. So we want to have the EU farm in there on port 9999. We want also, I'll add the Asia one as well. Also on 9999. Oh, sorry, wrong one. This one, this 80. And we also need a health check. So the load balancer will know when it's available. So we want to check health of Fabio. And then we have a backend, and we need to configure our front end. Our host path and rules, we simply move forward everything to the backend service. Front end configuration, we already have a static IP available, and we want to create this one. Well, review, yeah, everything fine. So what's wrong? Come on, what's wrong? Yeah, review, it's optional. Backend, it's not happy yet. So, come on. Oh, it has not created it at all, that's nice. New backend service, yeah. Great, come on. Blah. Farm, Asia, EU, yeah. Are you happy now? Create, yay. Okay. So in the meanwhile, we're gonna add some traffic to these. So I'm gonna. Yeah, time's up. Sorry. So we now have our global load balancer, which is probably not healthy yet. No, but if it would, then we could see our traffic to our backend move from the different locations to the local data centers, because Google does anycast IP routing to the local data center, so it doesn't need DNS to switch to a local region, which is pretty cool. And then if your local data center is not available, it will switch to the most nearest one, which I had hoped to demonstrate right now, but my time's up. Yeah, I have to leave it like this. I can show you probably in 5 minutes in the hall, but I need to make room for the next speaker, I guess. Or can I continue until he shows up? Hmm? Oh, you're already there. Yeah. Okay. Sorry. Okay. It was too. It's still not healthy yet. It takes a little bit. Okay, I'll show you all in the hallway if you're interested later on, or just ask me. Everything is on. Let's move to the end. Everything is on GitHub. So the whole. Oh, it's not showing. Come on. Okay, I'll. Slideshow. Come on. Current slide. There it is. So we can recreate it anytime with the scripts on GitHub, and all the other links are there as well. And I'll add a. I'll put up the presentation as well on the GitHub. Okay. Well, that concludes the talk then. Thanks for your patience.